This is the second video of queue. In the last video, I made some mistakes in the delete function, so I deleted that video and re-uploaded this video again. Hope this will help you more. So, what is a queue? Queue is a linear data structure which enables the user to add elements from rear and remove elements from the front end only, using the concept of FIFO, first in, first out. So, if you take an example, that is a real world example, that is when you buy a ticket from movie theater or railway, who enters in the counter first, at the counter first, who exits the counter first. Okay, so queue is like that, means the value which is entered at first, that value must be deleted first. Okay, since insertion and deletion both takes place from different ends, we have to keep record of the index of both the front as well as the rear end. Okay, consider a queue implemented using an array queue array. The index of the front first element is stored in the variable front and the index of the last element is stored in the variable rear. Okay, let the size of queue be denoted by the variable size. In our example, the value of size equals 5. Initially, the values of front and rear are 0, so insertion will start with index 0. Means first value that is inserted in the 0 location with the help of rear. You have to follow two things. When you insert a value, rear increases by 1, and when you delete a value, front increases by 1. Okay, so inserting an element in a queue. Since insertion in a queue takes place from the rear end, hence the first element which you insert in the queue must go to the rear end, which is at index 0, after which the value of rear should increase from 0 to 1 and to accommodate the next element. Similarly, when we insert the next element after insertion, the value of rear increase from 1 to 2 and so on. Means if you enter, just see this. Okay, just wait. Now when the last element is inserted index 4, the value of rear changes from 4 to 5. We now see that the queue is full and no more element can be inserted. This situation is known as overflow. So while inserting an element in the queue, always remember to check for a condition where the queue is full and no element can be inserted. Okay, so that is the example. Queue index 0, 1, 2, 3, 4, front and rear at 0, queue element 50. First, when 0 index is inserted, 0 index whether it's 50 is inserted, then the rear move to the 1 index. Next, the second value, that is 70, is stored in the 1 index, then rear increases by 1. Okay, so after the 5 value inserted, rear will be situated at 5 location. So if rear double equals size, then overflow will occur and you cannot insert any more element. In other case, you can insert by inserting at the rear end and increases the rear index. So while inserting, rear index increases if it is not matched with the size. So deleting element from a queue. The first element which you delete will be from the front index following the FIFO pattern. Before deleting, save the element and to be deleted and print or return as asked in the question. After that, the value of front index should increase from 0 to 1. Similarly, when we delete the next element, the value of front should increase from 1 to 2 and so on. Now, when the value of front and rear becomes equal, there will be no element in the queue. So we reset their values to 0. Denote that queue is now in its initial state empty. So now no more element can be deleted. The situation is known as underflow. So While deleting the element from the queue, always remember to check a condition where queue is empty and no more element can be deleted. Like, so first element deleted is 50, so front increases at one location. The next element 70 is deleted here, the front is moved at second location. So after deleting all the values, rear is at 5, front is at 5. So next process, you have to reset both the values at 0. Okay, so that is the position of underflow position. So if front double equals 0 and rear double equals 0, then underflow will occur and you cannot delete any more element. In other case, you can delete by increasing front. So while deleting front, index increases. So this is the example. So if I insert 5, okay, so I insert 5 here, okay, then rear will be increases. So rear, before inserting 5, rear is at 0, but now rear is at 1 index. Okay, again I insert 10. So as soon as I insert 10, rear move to the second location. Okay, now I insert 25. So as soon as I insert 25, rear increases at 3. Okay, now if I use delete function, then the front 0, now the front will be 1 and the value will be deleted. Again I insert value, that is 56. So I insert value at 56 and index rear stored and rear will be at 4th. Okay, now I use delete function again. So as soon as deleted, then the front will be at 2 index. Okay, and the 10 value will be deleted. And after that, if I insert 78, then rear equals 5. Means as soon as 75 inserted here, rear will be, okay, I need a little space, the rear will be 5. I just use in a bracket. Okay, I just insert an element, insert, right. So rear is at 5th index. So that is the thing. So if you delete any more values, means if you delete 25, then front is at 3. If you delete 56, front is at 4. And when you delete front is 75, then rear front is at 5th index. That means rear and front both are holding same value. That means you have to reset both values to 0 again, and it will show the queue is empty. Okay, or queue is underflow. So take an example. So that is the question. Queue is an entity which can hold maximum 100 integers. The queue enables the user to add integers from rear and remove integers from front. So you can see, when you have to add integers, it's from the rear end, and when you have to remove integers, it is from the front end. So that is the class. Define a class queue with the following details: class name queue, data members, queue array to hold the integer element, size stores the size of the array, front to point the index of the front, it is used for the delete purpose, rear to point the index of the rear, it is used for the insertion purpose. So queue int constructor to initialize the data, size equals front equals 0, rear equals 0. So you can see front and rear initial value is 0. And next, the function is void add delete int v. So v is the element to add integer from the rear if possible, display the rear if possible, else display the message overflow. So if the value insertion possible, then insert it. it is not possible, then print overflow, means not possible to insert. In delete, returns element from the front if possible, otherwise display the message underflow and return -9999. Void display the array elements. Now specify the class q giving details only the functions void add delete int and int delete. Assume that all other functions have been defined, the main function and algorithm need not to be written. So you need to declare only two functions, okay, and few variables. Looks like so that is create a class with q. I delete all the things now. First variable is q array, then size, then front, then rear. Okay, so I just declared int q, next int rear, front, and the last one is size. So now inside of constructor all the values is initialized, but here we have to do only two functions, that is void add delete int and int delete. Okay, so first function is void add delete, that is with parameter of int v, and now I check if rear double equals size, so it will print I think so on, just overflow, the word overflow, okay, else the value will be insertion possible. Then q first insert at the 0 location, that means you have to write 0 first, then increase the value for the next variable, next increase the rear value, which helps to insert the next element. So q rear plus plus equals v, so that is the void add delete function. Next we have to create just the function name is void delete delele, so I use void delele. So inside of that, first I check is rear double equals front. If it is, then rear equals 0 and front equals 0. As I told, whenever rear and front match, that means if just see at that location, I will show you that both are is at fifth location, that means there are no value to delete, that means you have to set both values by 0. Okay, so that thing you have to do here. So inside I just do that thing, and next after that we have to check the q is underflow or q will be able to insert values. So if rear double equals 0 double and front double equals 0, it means here you have to print system dot out dot println under flow and return minus double line, okay, as instructed in the program. And else part, return QUE front plus plus, okay. So that is the void delete function. So this mistake I did in the last last video, so I correct here. Sorry for that. Sorry, that is not void delete, that is a int delete, okay. So that is the complete program for this one. So next program is this. Link is an entity which can hold a maximum of 100 integers. Link enables the user to add elements from rear and remove integers from the front end and the end of the entity. Define a class link with the following details. Class name link, LNK array, which the entity holds the integer elements. Max, store the maximum capacity of the entity. Begin, to point the index of the front end. End, to point the index of the rear. So here rear is used a new name, that is end, and front is used a new name, that is begin, okay. Next member function link, that is the constructor to initialize max equals begin equals 0, end equals 0. Void add link int v, to add the element from the rear index if possible, otherwise display the message out of size. Int del link, to remove and return an element from the front index if possible, otherwise display the message empty ... and return minus double line. Void display the elements of the entity. Specify the class link, give details. Constructor, first we have to create constructor. Second, void add link. Next one, int delink, and last one, void display. So here we have to do 4 functions, and main function and algorithm need not to be written. So this one is with the 9 marks, but nowadays that is only 5 marks. So most probably you don't have to do all 4 functions, but it depends on the question. So what we have to do in that question? So first we have to create a class name with link, okay. Then delete all the things. Then I create int lnk array. Okay, just we have to see it again. Constructor int which is used for size, okay. We just declare int link with int the variable max begin and end. So max begin end, okay. So after that we have to create constructor first. So inside of constructor we have to pass So max equals begin equals 0, end equals 0, and we have to set array, that is lnk equals new int with the size of max, okay. After this we have to create that is add link int v, okay. Void add link int v. So in that area first we have to check the end, that is the new name of rear, okay. Sorry, it is if rear double equals max. If both are same, then it print system.out.println, it print I think out of size. Okay, out of size 3 dot, out of size 3 dots, else insert the value. So insert value will be stored in lnk third bracket end plus plus, means first you have to that is first value is end, that is 0. So lnk 0 is initialized with v. Okay, and if you again use add link, that is the next element v is you entered in lnk 1 index with the value of v. The next function is void del link that is not void, that is int. So in that case, first we have to check rear double equals, sorry, not rear, that is begin double equals end. If both are same, then begin equals 0 and end equals 0. Okay, so after that just check if begin double equals 0 double end double equals 0, system.out.println, I think what is so empty 3 dot, empty 3 dot return -99, and the else part is return the element, that is lnk third bracket front, not front, that is begin plus plus. Okay, that is return array begin, means if you delete the first element, that is lnk 0 index deleted and the begin is positioned at 1 index. Okay, so the last part we have to do void display the elements of the entity. Okay, so in that case void display system.out.println q elements are so here just check. So first you have to check begin double equals end. If both are same, system.out.println just print q is empty, and else you can print the elements. So now we have to create for int I equals front, I less than, sorry, that is not front, that is begin, I less than end, and I plus plus. So in that case system.out.println just I use print array name is lnk third bracket I third bracket close plus string that is this only separation purpose. Okay, so that is the final code of void display. That is the so there is the constructor, that is the void add link. If rear and max are same, then it is out of size, otherwise you can insert value. So when you have to delete a value from queue, first you have to check front, begin or end, or front and rear are same or not. If both are same, you reset their values. Now check if both are 0, then print empty or return something or anything you can do, and else delete the value. So when I delete lnk, the begin index value return with return and begin increases. Now when I use display function, if begin and end both are same, it prints queue is empty, otherwise it prints elements are begin. So if you think, just think at here, if the front is at that location, front is 2 and rear is situated at 5, that means you have to print 2 index value, 3 index value and 4th index value. That means you print those 3, that is 25, 56, 76, 75. So you have to start I with 2. Okay, that is I equals front. So 2 less than equals rear, sorry 2 less than rear, 5 true, 3 less than 5 true, 4 less than 5 true. But when the I value reaches 5, it will not able to print any value. Okay, so I write I equals begin, I less than end and I plus plus, and it is just a separator. So that is the complete program of queue. Bye bye.